Now in this session we go with the optical fiber acceptance angle, numerical aperture, expression for it and the fractional index change. Now let us see the ray propagation in fiber. In the previous session we have seen the total internal reflection to take place. Now in this we are going to see the ray propagation in the fiber. If the light is transmitted into the core of an optical fiber from the surrounding medium of refractive index n0 at an angle theta naught. Now you can see this diagram over here. This is an optical fiber. This is a core having refractive index of n1 and this is a cladding having refractive index of n2. If a ray of light is entering into the core having a refractive index n0, n0 is the refractive index of a medium where optical fiber is placed. Here it is in air, refractive index of air is n0 where it is in the medium. Now the ray of light is entering at the core at this point. Let that angle be theta naught. Now here if this is for a particular angle of incidence, the ray is undergoing refraction, and here at this point here when a ray is passing from a denser medium to a rarer medium, as core is a denser medium and cladding is a rarer medium, for particular angle of incidence it is refraction is total internal reflection is taking place. Instead of going from one medium to another medium, TIR, total internal reflection is been taken place and the ray is reflected back in the same medium. So here total internal reflection is happening. Now if we see for a smaller angle of incidence here theta 1, here you can see here it as theta I is less than theta naught. Theta naught be the reference angle. Let that theta I, angle of incidence, is less than theta naught. So what is happening when this angle is less? The angle theta I will be less. When this angle is theta I is less, this angle becomes 90 minus theta, because this is angle 90 degrees. So this angle becomes 90 minus theta. So what is happening here is for a smaller angle of incidence which is less than theta naught, the ray is entering into the core and at a point B, that is at the core and a cladding interface, TIR, total internal reflection, is taking place over here. That means for a smaller angle of incidence, that is theta I is less than theta naught. Theta naught is a reference angle. For smaller angles of incidence, the total internal reflection is taking place here, theta minus 90 minus theta here, and the ray is totally reflected back. Now if theta is increased, if theta I is increased, that means here if theta I is, the angle of incidence is increased here, which is equal to theta naught. So what is happening? This angle is increased. When this angle is increased, here the ray after entering into the core, theta I will be increased. So 90 minus theta will be decreased here. So what is happening here? As theta I is increased, the angle of incidence at the core and the cladding interface at B is equal to the critical angle. That means here you can see here this is the angle of incidence at B. The point, the ray at which the ray is entering into the core is called as point A, and the ray at which there is a total internal reflection to take place, that point is called as B. Now we have to see that at point B, if theta I is increased at A, theta I is equal to theta naught, then what is happening at point B? 90 minus theta I becomes equal to the critical angle, because here the ray is grazing the two medium, that is n1 and n2. That means this is R is equal to 90 degrees. Therefore 90 minus theta I is equal to critical angle. This is angle of incidence and this is angle of refraction. Here angle of incidence for which angle of refraction is 90 degrees. Therefore 90 minus theta is nothing but a critical angle. So when 90 minus theta is a critical angle at B, the angle of incidence is 90 minus theta I, which is equal to critical angle. Then the refracted ray is grazing the two medium joint n1 and n2. So when theta I is equal to theta naught, 90 minus theta is becoming equal to critical angle at a point B for which angle of refraction is 90 degrees. So this is a critical angle. Now if theta I is greater than theta naught, that means you can see here if theta I is greater than theta naught, if theta I is greater than theta naught, what is happening? At a point B, which this angle becomes less than the critical angle. When this is less than critical angle, then the ray is passing from one medium to the another medium. So you can see here the ray is entering into the cladding. The ray is entering into the cladding. So here the information is lost. That means the total internal reflection condition is not satisfied. When a ray passes from a denser medium to a rarer medium, if the angle of incidence is greater than the critical angle, then only total internal reflection will take place. Here at a point B, the angle of incidence here is less than critical angle, so the ray is entering into the cladding. So information, total internal reflection is not taking place, and the information which has to be transmitted into the optical fiber is being lost and is entering into the cable. So in this there is no total internal reflection happening in this case. So these are the three ways in which the total internal reflections, what are the cases where the total internal reflection will take place. Next we see the expression for acceptance angle or a numerical aperture. We see the derive an expression for a numerical aperture and what is called as an acceptance angle. In the previous cases we have seen that. Let us consider a special case where the ray suffers a critical incidence at a point B. That means second case which we have discussed. Consider a case at a point B. At a point B, this angle becomes a critical angle and theta I is equal to theta naught. And N0 is the refractive index of the air, N1 is the refractive index of the core, and N2 is the refractive index of the cladding. Now we are going to see point A is nothing but the ray of light ray entering into the core is at A, and light ray entering at the core and cladding interface is B. For an angle of incidence at B is equal to critical angles, we are considering this case. And here it is a condition N1 is greater than, N2 is greater than N0. That is N0 is a rarer medium and N2 is a little rarer medium. That is little bit. Between these two, N2 becomes denser medium, but N1 is more denser. N1 refractive index of core is more than the cladding. Then cladding refractive index is greater than the refractive index of the medium where the optical fiber is being placed. Refraction at OA, refraction at ray OA at the entry point at core A by Snell's law, N0 sin theta naught is equal to N1 sin theta 1. That be equation 1. That is here. N1 sin theta 1 is equal to N2 sin theta 2. It is a Snell's law. So here N0 is the refractive index of medium in which the optical fiber is placed. N0 sin theta naught is equal to N1 sin theta 1. This is nothing but sin theta 1. This is theta naught and this is theta 1. So this is the angle of at a point A. This is the equation by Snell's law. Next, at a point B, the angle of incidence is 90 degrees. Here at a point B, the angle of incidence is 90 minus theta 1. So what is happening here by Snell's law? Applying Snell's law at B, we know that N1 sin of 90 minus theta is equal to N2 sin of 90. 90 minus theta is nothing but a cos theta. So N1 cos theta 1 is equal to N2. Sin 90 is 1. So it is N2. So cos theta 1 is equal to N2 by N. Rewriting equation 1, we have sin theta naught. In the equation 1, we have seen in the previous slide, sin theta 1 can be written as N1 by N2 into N0 by N1 into, see here. Here we are writing sin theta naught here. So sin theta naught can be written as, bring this N0 to here. So N1 by N0 into sin theta 1. Substituting here, N0 by N1 is equal to sin theta naught is equal to N1 by N0 into sin theta 1. Rewriting sin theta as root of 1 minus cos square theta and substituting the value of cos theta from this equation, N2 by N1. Rearranging this form, sin theta naught is equal to N1 by N2 into root of 1 minus N1 square by N2 square by N1 square. Simplifying this, you are getting root of N1 square minus N2 square by N0. That means sin theta naught is equal to root of N1 square minus N2 square by N0. If the surrounding medium is air, then N0 is equal to 1. Therefore, sin theta naught is equal to root of N1 square minus N2 square. Here, theta naught is called as an angle of acceptance, and sin of angle of acceptance is nothing but a numerical aperture. So, sin theta naught is nothing but Na is equal to sin theta naught is equal to root of N1 square minus N2 square. Here Na can be written as N1 square minus N2 square by N0. If N0 is equal to 1, then N0 goes to 0. So denominator will be 1 here. Now what is angle of accept? It is a maximum angle of incidence on core for which the total internal reflection takes place inside the core. So it is a maximum angle of incidence on core for which the total internal reflection takes place inside the core. What is the propagation? Condition for propagation. theta I is less than theta naught. Sin theta I, taking sin on both sides, theta I is less than sin theta naught. Then theta naught is nothing but Na. So sin theta I is less than Na. This is the condition. That means in order to undergo total internal reflection, theta I should always be less than theta naught. This is the condition of propagation. Next is fractional index change. Fractional index change is the ratio of refractive index difference between the core and the cladding to the refractive index of the core of an optical fiber. It is a ratio of difference in the refractive indices of the core and cladding to the refractive index of the core. That is N1 minus N2 by N1. Rearranging the terms, N1 minus N2 is nothing but delta N1. We know that Na is equal to root of N1 square minus N2 square. It is in the form of A square minus B square. So it can be written as A plus B into A minus B. And here we are replacing N1 minus N2 as delta N1. So N1 minus N2 as can be taken as delta N1. Since N1 is approximated to equal to N2, so N1 plus N2 can be written as 2N1. So this equation reduces to Na is equal to root of 2N1 into delta, bringing out Na is equal to N1 into root of 2 into delta. Delta is nothing but a fractional index change. It is a ratio of difference in the refractive indices of the core and cladding to the refractive indices of the core. Thank you.